Alright, in this video I'm going to talk about dictionaries. It's another data structure you can use in Python. I will say now I may slip up and call, instead of saying dictionary, I may say associative array, or I may say a hash table. But all three of those are the same thing. There's actually a little bit of an analogy you can make with using the term dictionary that kind of makes sense, so I can kind of see why they called it that. But for a quick review, we've talked about three data types so far. Not data types, three ways of storing data into memory. One was your generic variable. We'll just say we named this one var, and you arbitrarily name it, and it stores something in there, like like a string and an integer, a float, what have you. The second one is a list, and we just say we called it my list, and once again you'd arbitrarily name it, and then it would point to zero or more things in memory, because you could actually have an empty list, or you could have a list with one thing in it, or two things, three things, four things, but however many, and they can be of mixed type. So you could have if a list has like 5 items in there, you could have strings and integers and floats and all that. And then the way this one actually works is it points to the beginning of the list, and then you use an offset to get to the rest of the data. And if this one seems confusing about to you, I spent like the last 2 videos I talked about it, so go check that out. This third one we're going to talk about now is the dictionary. Let's just make this big squiggly line here and say that this big blob here represents all the possible memory, all the memory you have access to with your computer, your RAM, and everything else. Then what a dictionary would be is you'd have a named piece, or arbitrarily named once again. But instead of having all the data lined up, in a row in memory where you can choose an offset to access it, you instead use a unique key. And when I say unique, it's unique for each dictionary. Like if you had 2 different dictionaries in your program, and then you could use the same key once for each one of the dictionaries. You can't use the same key twice in the same dictionary. And the keys will be what's called immutable types. Basically, an immutable type, just for now, let's just say because immutable type is kind of an object-oriented thing. We haven't got there yet, so let's just say that you can use strings and integers and things like that as keys, and it's perfectly fine. So, like, say I just have one key that I call key, another one that I call age. I have another one that's just the number 5, and another one that's the number 10. Then each one of these will point out somewhere in this blob of memory where you've actually have the data associated with it stored. You may ask, well, why is that useful? Well, one quick example of how it would be useful is, say that you're dealing with a list here. They're fantastic when you have you're on a bunch of data that's all associated with the same thing, maybe like all people's ages or something like that. But when you have it with like different, where maybe you have data grouped together for a person, or for you're programming like a dog or whatever, then there might be a bunch of data associated with this thing that you're programming, but none of the data directly corresponds with each other. Well, then just by having these keys, you can quickly access it. You just say, I want the person's age, and bam, you've got it, or his key number for his employee login or what have you. So that's one example of it. Another much higher or much lower level example, and this is kind of to give you an idea of one big use for these. That's not going into too much detail. When you actually program in Python or C or C++ or Java or pretty much any programming language, then you're actually going to and Java is huge on this. When you create new things like variables and things like that, that the compiler or the interpreter has to keep track of, like what it's called and where to find it in memory, they actually often use dictionaries to do that. So, like, say when you actually made this, if we were talking about the dictionary that's associated with the Python interpreter, when you made the variable var, it would actually put var in its dictionary. Var would be the key, and it would point to whatever data you saved there. So that's one real life example of hash table being in action, or dictionary, excuse me. You actually use them. You've been using them since you've programmed. It's been behind the scenes, it's been done for you, so you haven't realized it. Alright, on the code here, just some quick code examples. I went ahead and just typed it all out. Once again, there are methods associated with the dictionary just like there were with lists. I'll pull a website over so you can look at the web address. I don't plan on doing a second video on this where I walk you through all the methods. I'll let you see what they are and what they're called. And this place has, I think this website that I'm pulling up is going to have some examples for some of them, and start getting you comfortable with the idea of running with programming yourself. Because I can drone all day long about stuff like that, but honestly, until you start, messing with it yourself, then you won't get really comfortable and get the confidence you need. And a big part of programming is confidence. Once you kind of get the basics down and get some confidence, then you'll be running off learning new languages left and right. Anyway, so with dictionary, actually, I'm going to go ahead and put right here. I'm just going to say, just to show you the syntax. If you want an empty dictionary, when you want an empty list, you use this empty square brackets. Well, with an empty dictionary, it uses curly braces. So that would be the syntax for an empty dictionary. And then here's where I'm actually assigning stuff. I'm hard coding stuff into the dictionary. I say my dictionary equals, and then first the syntax is you put a key, which like I said could be a string or an integer. For now, it's fine to go with a colon, and then what data you want to associate with that key. So here I say I have the key age. I want the number 50 associated with it. Here I say I have the key industry. I want the number or I want the word banking associated with it, or the string banking. Once again I separate it by colon. Now this one I say I want my key to be the integer number 5, and I want to associate a list with it. And then each time you go to a new key data set, you use a comma to separate the next one. Another little side note I put in here. You'll notice that I have this weird notation with this list. I have 1, 2, 3, 4, 1, 2, 3, 4, and then it looks like I open another list up and do 5, 6, 7, 8, and then I've got the two brackets at the end together. Well, I forgot to show these in the list video, which you're actually allowed, just like the dictionary data structure allows the list data structure in it. The list data structure will actually allow you to store other data structures inside of it, including another list. So this list actually has another list inside of it, and you'll see it when I print the stuff out. But anyway, that's how you set it up. And then I go through and I just print the data I have so far. I say age is, and then the way you call the data is you say, it goes back to square bracket notation. You say my dictionary, or whatever the variable name is, then you put the key inside of the square brackets. And that will, my dictionary of age would print out the 50 here. My dictionary of industry would print out the string banking. And then on this one, it looks more like list notation, because I'm using an integer, but it's this integer here, 5, which is the key for this list, so to print that list out. And then here is the notation for adding a new item into the dictionary. You'd say my dictionary, and then once again it looks like list notation because you got square brackets, but inside of that you put your key and say equals whatever you want to save. So I say the string entered into the dictionary, and I associate it with the key new entry, and then just print it out again. And then finally I print out the whole list. And then if we actually run this, you'll see all this stuff going on. What do I call this? There we go. And then here's where I save it, which doesn't show anything obviously. And my print statements are here. I say print age is, and it says age is 50. Well, the key of age is associated with the number 50, the integer 50. Here I say industry is, and then I say my dictionary of industry is my key. The key of industry is associated with the string banking, which is what I print out there. And then I say key 5 is, and I actually call it by saying my dictionary key of 5, and it spits out this double list there, which is what we expect. And then I save entered with the key, associate the word entered in the dictionary with a string with the key of new entry, print that out, and it says new entry is entered. And then finally I print out the entire dictionary, which is just all this stuff there. And you'll notice here that when you print out the dictionary, the key order doesn't necessarily match the key order here. Alright, and then finally, I just Googled this. You may find some better site for it, I don't know. But I just Googled dictionary methods, for Python 2.7. Because I honestly, like you get so many data types and so many things with so many functions and methods associated with them, you're not going to remember them all. You're going to kind of always have to keep a reference. That's why documentation is so handy. You can look stuff up, and a lot of times they have examples. But anyway, this is just a list of all of them, and I'll leave you guys to play with that and see what you can do with it. Anyway, there's one website if you want to just type this one in. If not, then you can just Google it.